Hello, the internet. Welcome to Open Source Directions by OpenTeams, the webinar that brings you all of the news about the future of your favorite open source projects. My name is Madikin. I'm a postdoc at the University of Illinois, and I work on a project called YT. And I'm so excited this week to be joined by this week's guest co-host, Melissa, as well as our guests.
Hi, I'm Melissa. I'm currently working as a software engineer at QuantSight, doing some work on NumPy and also F2Py.
Hello, my name is Ondřej. I'm a scientist at Los Alamos National Laboratory, and I'm also the original author of SymPy, SymEngine, and Fortran.
Hey everybody, I'm Milan. I'm a scientist at the University of Miami. I study ocean waves in hurricanes, and I'm also co-founder of CloudRun, which is a SaaS for numerical weather prediction.
Awesome. So our generous guests are offering 10 lucky guests free ebook codes for modern Fortran. So check the chat to find the link to the raffle, and please add your email addresses. The first 10 viewers to register will be sent the book codes within 24 hours. So before we dive into the project a little bit, we're going to do a little personalization section. And this week we have our new hybrid Tweet of the Week plus headline section, where each of our panelists presents a tweet and or open source headline that they've been enjoying recently. Milan, I think you're going to be first up.
All right, so my favorite tweet recently is from Andy Kelly. So Andy Kelly is the author of the Zig language, and he tweets a lot about it and writes blog posts and streams on Twitch, live programming of features of the compiler. But the specific tweet is about how Zig can finally be used as a drop-in replacement for GCC and Clang, and can cross-compile to various platforms from the platform you're on, which is pretty mind-blowing to me.
Yeah, that's pretty amazing. Andre, how about you? Do you have a thing to share with us?
I found one favorite tweet yesterday, actually, from Stefan Karpinski, who's one of the Julia developers, who was saying that they always work very hard to speed up the Julia compiler, so they managed a 10% speed up, which is a lot of work, and then they upgraded to a new LLVM version, which got 10% slower, so it negated their hard work. So it's very, very frustrating.
Oh no. Okay, Melissa?
So I have this interesting tweet by Scott Birkin. He's an author on creativity and other stuff. And he's talking about how to foster a sense of community. So he mentions, like, when you build a Slack channel or you have a forum for your users, when they join, they need interaction. So they need you to respond to their questions, to say hi, to use emojis, and just overall build a sense of community. So I thought it was interesting to think about that.
Yeah, I think this is like a challenge for all of us, right? To make sure we're interacting with our users and developers frequently, and like have some sort of quick turnaround without dedicating all of our time to that. Okay, so mine is actually a headline from Bloomberg. So Bloomberg developed BQplot in the org itself, and BQplot is a library for interactive plotting, and now they are spinning out into their own open source organization. So BQplot, welcome to the open source sort of area and having your own org. Yay. Okay, so now we're going to get into the project and introduce Fortran a little bit. Fortran doesn't really need any introductions, but we're still going to do it. So Fortran is a language for scientific numerical array-oriented computing. Fortran itself has 195 stars on GitHub across all community Fortran-Lang Dot Org projects. It has 16 active contributors and 97 pull requests merged or closed since December, which is super impressive.
So, Ondřej, can you talk about why this project was started and which kind of needs it fills?
So Fortran itself is a very old language. The first release was 1957, but the modern need for Fortran, and so historically it's been the first high-level language. That's why they started it. The modern need for Fortran is a simple language that domain scientists can use and develop and to maintain large codes in, and also simple, but also be easy for compilers to generate very high-performing code. And then, so Fortran has been around for 70 years or so, but what Fortran is missing is a central place at the internet, at GitHub, for example, where we can build a community and can have things where modern users are used to, such as community owned compiler, documentation, standard library, package manager, packages, all this ecosystem of things that every new language like Rust, Go, Julia has, except Fortran. Even C++ has way more tooling than Fortran has. And so what we are trying to do here is to create a website and build a community and to start building all these necessary toolings.
That's fantastic. And also building a Fortran community sounds like a really exciting thing to get involved in for both our listeners and also myself. Yeah. So Milan, can you explain the history of the name and the logo?
Yes, so the name, if you take the word Fortran, for comes from formula and tran from translator. So you have the formula translator. That was the very first, basically how the language was introduced as the first high-level language, which basically allowed scientists and engineers at the time, which were most of the users of computers at the time, it allowed them to write programs in a language that was very natural to them, basically to type in code that was essentially like the math that you would write out on paper or on a whiteboard. So it was pretty revolutionary at the time and consequently influenced many languages to follow. Now, about logo, so Fortran traditionally has not had an official logo or a website, and that's part of what we are trying to change. When we recently designed the Fortran-Lang Dot Org website, we also adopted a logo which was originally designed by Jacob Williams. I tweaked some colors to fit the theme of the website. By the way, that's a very fresh and new project, and I will show it a bit later, but yeah, the site has been up as of a week ago.
And can you talk a bit about alternative projects to Fortran and also how they talk to Fortran in terms of interoperability?
So from a user perspective, I think how Fortran feels, it's close to MATLAB, Python/NumPy, and Julia. Those would be the three kind of main languages that kind of feel from the user perspective the same. From a performance perspective, I would say C++ is the main competitor. Maybe Rust, maybe Julia. And then regarding how the languages talk to each other. So for example, when you want to call Fortran from Python, the go-to tool is called F2Py. It used to have many different places where it lived. Now it's part of NumPy. A common question is, what is the advantage of having L-Fortran compared to F2Py? So L-Fortran is a compiler that I've been developing for the last few years. And the idea of L-Fortran is that it will become a compiler that can compile any code eventually. And it's able to expose you the internal data structures in a very user-friendly way. And then people can write backends to it. So the backends that I'm currently working on are LLVM, of course, and C++ backend. And I'll also soon start working on a Python backend, which would allow to automatically wrap any code. And so down the road, in a few years, what I'm hoping is that F2Py, for example, could just be a backend that can reuse all the infrastructure from the compiler to ensure that things can be parsed easily, quickly, robustly, and F2Py can concentrate on the actual wrapping mechanism. Currently, the way it is, F2Py has to do everything, has to do parsing, has to do all the things that a compiler should be doing much more efficiently and easier.
Can you tell us a little bit about what technology Fortran is built on?
So Fortran is a language that has an ISO standard specification, and the compiler can be implemented using any appropriate technology. There are many compilers out there. So from the open source compilers, the most advanced is Fortran. And then there are new compilers, open source compilers in development. One is Flang, now part of LLVM, and also Fortran. And then from the commercial compilers, there is Intel, there is PGI, there is Cray, there is IBM, there is many of them, NAG. And so Fortran historically, it's part of GCC, so they have their own tool chain. Flang and Fortran both are targeting LLVM. Intel and IBM are also, looks like maybe moving towards LLVM based infrastructure, but traditionally Intel has its own code generation, and Intel from all the Fortran compilers is traditionally, and I think it's still the case today, it generates the most performing code on Intel architectures.
Milan, can you tell us a bit about the history of the project and who created it?
Yeah, so Andre mentioned earlier that Fortran was started at IBM in the 1950s. So its main developer was John Backus and his team. So the main goal of Fortran at the time was to allow people to write high-level code in a language that is natural to them, like I mentioned earlier. And the compiler was very successful also for the reason that it was the first optimizing compiler. So before that, people had to write by hand assembly or machine code, which means that what you wrote, that was what was running. But for the first time, compiler was doing automatically the work of translating from human readable language and optimizing the code that would run very fast. So Fortran had a very sort of solid and successful start from the get-go, which allowed it to become, over time, very mature and very highly performing language, because compiler developers over time built over the foundation that came from before, and that's what allowed Fortran to still have its place today in part.
Okay, cool. So like a little bit earlier where you mentioned that there's 16 active contributors to the project. Can you tell us who maintains the project and about how many people that is?
So those pull requests and maintainers, those are kind of maintainers for our very new project, Fortran-Lang Dot Org and the related repositories. So Fortran as a language, traditionally there's nobody who has maintained the language. There is a Fortran Standards Committee, which maintains the ISO standard of the language itself. And I'm also part of the committee, and Milan will soon hopefully also be part of the committee. The committee has maybe 10, 15 people, and they meet. They are responsible for releasing the Fortran standards. So the latest standards, for example, 2018. However, currently there is no open source community like Julia or Rust has that stewards the project. And that's exactly what we are trying to fix.
What communities are users and contributors from?
So basically science and engineering, various fields across the two. So recently, our colleague Damien Rousson told me he likes to say to people how where Fortran is used a lot today are in industries and communities that have adopted computation early, which was in the 50s and 60s, and that's where Fortran is very powerful and mature for these kind of applications. So more specifically, fluid dynamics, that includes aerodynamics, numerical weather prediction. So we look at weather forecast almost every day in various forms, whether on website or app or newspaper, whatever. So that comes from large Fortran codes that run on very large computers. to solve PDs over the whole globe to compute a solution for the future state of the atmosphere or ocean. And likewise for climate prediction and climate change, that's essentially 100% Fortran. And also more recently, we get some overlap with people who work on Python and especially NumPy and some SciPy ecosystems, Julia and similar.
And also one field that you forgot to mention is electronic structure calculations, essentially using quantum mechanics to do material predictions. That's mostly Fortran also. It's a huge field.
Yeah, it's amazing how it's so ubiquitous in science. I mean, my training is in nuclear engineering, and I will definitely attest to the fact that there's a lot of software in nuclear engineering that uses Fortran, and it's very performant because of that. And so I'd like to remind our listeners that they can ask questions in the chat, and we'll ask them a little bit later in the webinar. And so as we go through this section or the following sections, if there's anything that you want clarification on, or maybe you want to ask our guests about, please add them to the chat and we'll make sure to ask your question. Okay, so our next question is the project participating in any diversity and inclusion efforts?
So it's a very new project. We just started it late last year. So the main thing that we are trying to do is ensure that anybody who comes, any new user, will give a helping hand to him or her, and that they feel welcomed, and that any idea can be discussed freely. For that purpose, we also have a code of conduct, and we are enforcing it. Unfortunately, we already had to enforce it a few times. I have a lot of experience maintaining large open source communities from SymPy. Been doing it for over 10 years. And in general, at least from my SymPy experience, it has to be enforced at the beginning, but once people learn, yes, you just have to behave professionally at all times. The community itself, it doesn't have to be enforced anymore because the community itself doesn't have these issues. But at the very beginning, it's very important to enforce it, and so I take that very seriously.
Well, that's really great to hear, and it's true. Like, building community in this way really helps make your community sustainable as well, right? Because you will retain people if you have strong infrastructure within your community.
Exactly.
So now we're going to switch a little bit into our project demo / walkthrough, where we'll get to see some of the cool features of Fortran and how it works. And while our guests are getting set up, we'd like to take this opportunity to thank our sponsor, Quansight, for sponsoring this episode of Open Source Directions. Quansight, creating value from data. So when you all are ready, please take it away.
All right, so I'll start, and basically the first thing I want to show you is the Fortran-Lang Dot Org, which is a brand new website. The main goal behind this is to give Fortran a home on the internet that is easy to find, that for when people search for Fortran or are curious about Fortran or just want to get started, they can come here and have all the resources they need. So to learn about what the language is about, to learn about the latest news from the language and the community, and to be able to learn. So basically, we want to have sort of a go-to tutorial for Fortran that will allow people who are new to the language just come here and get started step by step in a practical, hand-on, no-nonsense way to be able to write basic and correct Fortran software easily and quickly. And so this is a very, very, very early development kind of project. And actually, for example, the current state of the tutorial, which is very sort of early and bare bones, it was just contributed by a member from the community. Then we also want to provide resources for compilers. As Andre pointed out, there are several open source and commercial compilers. So this page will point you to where and how you can get various Fortran compilers. And then development. We want to also sort of refer people if they're more interested in learning and contributing to the project to sort of go to there from this website. So here we have Fortran proposals, which Andre will discuss a little bit later, and also the standard library and the package manager. So these take you directly to GitHub of the project. And just to give you a little bit of background about the standard library. So a common sort of complaint or criticism of Fortran that I hear from people is Fortran doesn't have a standard library. Not in a typical sense like, say, Python has, or Go has, or Rust, which are very sort of comprehensive sets of tools for formatting, strings, algorithms, collections, and so on. So Fortran has its own built-in library. In Fortran terminology, this is called intrinsic functions and modules. This is, before we started building any kind of standard library, which is what I'll show here, people had these intrinsic functions out of the box, but anything extra that you needed to do, if you wanted to format strings in a special way, or if you wanted to parse dates and times, you had to build it yourself. Just for an example, in about 2013, I needed to parse some dates and times and process them in a physics model. I looked around. It turns out Fortran didn't have a ready solution for that. In Python, you just go get date time, go get time delta, and you're off to the races. So the time I made a Fortran library that very much modeled the Python date time and time delta API, which is now rather popular and used in some big production codes. But this sort of anecdote illustrates you the problem of the lack of Fortran package ecosystem. And basically, the idea for the Fortran standard library, which I'm showing you now, came in, I think, November or December last year in the project that Andre initiated, the project to basically develop proposals for the standard by the community on GitHub. And the common theme there was that there were a lot of requests for sort of basic functionality that could be implemented in Fortran as a library, but these requests were being sort of made to the standards committee to implement in the language that would then be implemented by the compiler. So there's this long kind of roundabout process. And for many of these things, you could just go and implement a function or a module as a library. So that's where Fortran Standard Library comes from. And since then, I think Madikin mentioned we had, in this specific project, we had 12 active contributors. We have sort of a well-defined workflow on how we're adopting the additions to the library. So we have sort of a 5-stage process where we go from idea to the API, to the specification, to the implementation, finally to the release. And at every step, we require that we have a majority agreement from the community before going forward. And the majority is here sort of arbitrary. Like we want 80-20 sort of majority agreement on a feature before going forward. We don't necessarily want everybody to agree because then a lot of work won't get done, because there's always, we all have sort of personal perspectives on what should or shouldn't be in the standard library, how should something be implemented. You get the idea. So right now, from the top of my head, we have several modules that each have, on average, I think they add about several new functions. So we have a module for parsing and working with ASCII character set. We have error handling, still very basic for right now. We have a module for basic I/O functionality. We have a really nice module and function which makes it easier to work with optional arguments in Fortran function subroutines, which is as defined by the language. It's kind of tedious right now. So this function sort of gives you like a drop-in. It's sort of like a syntactic sugar. Just makes it a little bit more pleasant to work with optional arguments. And a lot of work has been done by contributors from the community for quadrature, basically integration methods, statistics methods, and we also have some basic system functionality. So the project is still very, very early on in development, but I do encourage anybody listening who is interested in working with Fortran or is working with Fortran already, take a look and see how you can use stdlib for your project. If there's anything that you like to be part of the standard library, please join the community and get engaged. We always we welcome more people and we need more help. So please join us.
And I would also mention the scope. So initially we envisioned stdlib to kind of help out with kind of basic things like string manipulation, but we realized the scope really should be something like SciPy, and NumPy is for Python. The idea is that if you want to use Python, you have to typically install NumPy and SciPy to do any kind of numerical thing. Another way to look at it is as if you have MATLAB, you have these batteries included. So that's roughly the scope of stdlib, is to provide this basic functionality so that if you want to do numerical things in Fortran, stdlib should get you there. And then once you need something more specialized or faster or anything else, then of course you use other packages. One question is stdlib targeted at the most recent specification, or can it be used on older projects? It's a very good question. It can be used for older projects. We haven't. Right now, we don't use anything fancy from the latest Fortran revisions. We will eventually figure out which exact Fortran version we are targeting. But right now, it can be used with, we don't use anything from 2018, for example, or probably not even 2008. All right, so I think the next part I'd like to show is the J3 GitHub website. Hey,
Andre, do you think why don't we show FPM real briefly, just one minute, and then I'll hand it over to you. Sounds good?
Okay, go ahead.
Okay, so FPM, which stands for the Fortran Package Manager, comes from basically another sort of very basic and fundamental need, and it is to have a tool to easily build your Fortran project and incorporate dependencies to your Fortran project without having to handwrite your make files or CMake lists or whatever have you, and also to connect to the ecosystem of FPM supported projects on the web. So basically think, Cargo for Rust or NPM for Node, or others. Anyhow, so this specific project, really, what sparked it was a thread that Dominic Gronkiewicz started, and then Andre and I sort of refined the ideas. And now, so Bren Richardson and Andre are leading development of the Fortran Package Manager right now. And this is very, very early infancy kind of project, basically pre-alpha, much younger than STT-lib even. But I do encourage you to explore it, open an issue if you have ideas, try to play with it. And yeah, like I said earlier, let us know what you think, or if you can help in any way, that would be great. So right now I would like to hand it over to Andre. So,
thank you. Yeah, I'll just mention with the FPM, the idea is, as Mila mentioned, so I like the Rust ecosystem the most. You can very easily install different versions of packages, and everything installs in your kind of directory with the project. And then when you create a new Fortran, or let's say new Rust project, all you have to do is just create a very simple cargo.toml. And if you use a predefined layout, you don't even have to tell Rust where all your files are. The cargo can figure it out. And so that's the same approach we are trying to do with FPM, which will make it very easy for people to create packages. And FPM will figure out how to compile it with any Fortran compiler on any platform out of the box, in release and debug modes. That's another common issue in Fortran. People don't know what flags they should put to, let's say, Fortran to get the most optimized build. You have to use ARC, native and fast math, and you have to use, unroll loops, all these O3, and actually stack arrays. They just keep stacking up. You have to know that, and FPM should know that and do it for you. So you do release, it will just do it for you correctly.
It really sounds like you're making the development process for Fortran a lot easier, and also making it more accessible to a lot of levels of developers, right? Yes. Oh, that's the other thing. Yes, we want to, and that kind of ties to what I'm going to show you next with Fortran. What I'm hoping is to get people involved in building these tools for Fortran. Okay, so can you see my screen? Yes, we can. Okay, so as I mentioned before, I'm on the Fortran Standards Committee. So historically, the committee has not been very good at engaging the wider community. And one of the issues that I realized quickly is we should have a website where anybody can propose a new addition to the language and discuss it. And so I started this J3 Fortran repository. J3 is a name for the US Fortran Standards Committee. So the Fortran Proposals repository, if you go to issues, then we are tracking anything that the committee does, and anybody can, if you want, say you don't like some language feature, you would like to propose a new feature, you can just come here, create an issue, and we'll discuss it. When you sort it by popularity, you can see what people want to see next. For example, they would, people like to be releasing the Fortran standard sooner than every 5 years. They would like to see, for example, the top voted proposal is, I'll just go into it so that you can see. So Milan started it, be able to set default values for optional arguments. This is how it is done currently. It'd be nice if one can, for example, use some kind of a syntax like that, or maybe even better, have the syntax inside, and so on. Anyway, and so then people can vote on it. You can see it has a lot of votes, 14, and so on. And you can see it's long discussion of pros and cons of various, changes and so on. All right, and then I'll move on to the next part, which is, so that's a binder. So I want to show you how Fortran works in the Jupyter Notebook. And I have a binder, but every time I want to show the binder, it somehow doesn't work. So what I'm going to show you is a local version. But at home, you can go to Fortran.org and click on this link, binder, it will work. It just have to wait a little bit. But what I'm going to show you is just a local version so that we can go ahead. So in the notebook, the Fortran allows you to use Fortran interactively. And so you execute a cell and it gives you the output right there. It looks like Python or Julia, but it's a Fortran syntax and it's a Fortran full-blown Fortran compiler. I want to show you, people usually ask what happens if I declare a variable I. It's first I assign to it, it's an integer, and I try to assign something else to it.
So I get a compiler error, unlike in Python, which Python would reassign the variable I. Then you can declare functions, you can call them, you can redeclare a function just like in Python, and so then you can get a different answer. It has loops. You can see print something out. It's hooked up. This is just a prototype showing how it can be hooked up to Matplotlib to do plotting. Matplotlib is quite slow, but here it is. Of course, so that you believe me that it's not, that it's real, you can change. I'm just kind of plotting the y coordinates of things. So if you change it and then plot it, you get a different plot. And then one can also see how the compiler works. So one can show an AST of the Fortran code, or the LLVM code that it generates, or assembly code also. So this is just a prototype that I wrote. This is from about 9 months ago or so. The prototype is written in Python, but since then I moved to C++, and now I'm kind of getting up to speed and getting everything ready in C++. And the reason I moved from Python to C++ is for robustness and speed, and it's easier to distribute, and it's also much faster. So I think that's all I have.
Well, this is fantastic, and it's really nice to see the different levels at which we can now be interacting with Fortran. So that's also really exciting. And I know you've already kind of talked a little bit about, the early infancy of some of these projects. And so this is actually a perfect transition for us to go into the roadmap of Fortran. So we're going to be talking a little bit about now where Fortran is going. And for our listeners, these are places that you can get involved in the project, or if you work at a company, maybe you could dedicate some developer hours or funding to some of these initiatives. And so first we're going to let Andre and Milan kind of talk about some of these, and then we're going to go, do a little more freeform and explore where these roadmap items are going to be going. So why don't you two let us know what's on the roadmap for Fortran?
Okay. So the main number one thing that we are trying to do is to build a community. Fortran has a large community, but it's scattered. It's not around some website, and that's the number one thing we are trying to fix. Because once we can fix that, people can actually collaborate together and build all these tools very quickly. Typically, historically, Fortran, for example, has for the stdlib, there's about 10 libraries that people have written, including myself, for one, just kind of basic utilities. And we realized, that's ridiculous. We need to do it. We need to come together and do it into one library, just like SciPy began, same idea.
Yeah.
All right, so that's the number one. But then some details. So we want to have a community open source compilers, Fortran, Lang, and others. We want to have a website. We already have it, Fortran-Lang Dot Org. We want to have a place to ask questions. We want to have a place where anybody can propose new features to the language. So we now have it. I showed you the J3 GitHub repository. We want to have a rich ecosystem of packages and a package manager. We call it FPM, Fortran Package Manager, and Milan showed you how it works. We want to have a Fortran standard library. And I'll quickly answer one question here. It was, what about a scientific library repository similar perhaps to R, CRAN? Yes, that's the idea, having a repository where people can upload FPM packages, similar to how Cargo, for example, does it, or Python too. Then question is, what's a success metric? Like, how do we determine that we are moving in the right direction? It's actually super easy. There's just the main metric is how many people are choosing Fortran for new projects. And right now it's almost nobody. And once we can see on GitHub, for example, we look at the last new projects in the last year. Once we can see that people are using Fortran for new projects, then that means we are successful. A secondary metric, of course, is, once we have the FPM registry going, how many people submit packages, number of stars on various projects like FPM, Fortran, stdlib. Another success, or kind of seeing that we are successful, is once people will stop kind of thinking of Fortran as a dead language, or kind of language that's not in a good shape.
Right.
And that all will come later. So that's roughly our roadmap.
Okay, great. So I have a question kind of related to building community. So you have created a lot of infrastructure for building community, and I think it's going to be really great for people who are new to the language and learning it. But how do you kind of disseminate some of these community tools to communities that are already using Fortran, that have been using it in some workflow for the same way for a really long time, and maybe don't know about this? Are you expecting sort of a word of mouth thing from existing domain scientists to kind of spread this to people, or do you have any plans specifically to make sure you're advertising it to those communities?
Yeah, so we want to get a solid product kind of first, so that when it comes, to give you an example, let's say from my employer. So we have these large production codes in Fortran, but those are codes that are used every day. They have to work,
Right.
and so it's too early to be advertising something like this to those managers managing those codes. However, but we need to get there, and to get there, so what we are kind of doing now is trying to get people who are interested in developing new things and understand that it's at the beginning. It takes time. Once we are more mature and we have some success, let's say some good FPM packages that work, and it's kind of more production ready, then it's time to bring this more to attention to people who use Fortran in production. One thing I should mention at this point is people maybe don't quite realize, let's say C++ or Python have very healthy ecosystems. And what it means is that you have small projects. People use C++ and Python for new projects all the time. So you have small projects, medium-sized projects, and very large production codes. What Fortran has, it has a lot of very large, multi-million lines of production codes, many. Every huge organization, from all the labs have that, NASA has it, in industry. However, Fortran doesn't have, almost nobody is using Fortran for new projects. That's easy to check at GitHub, for example. And there are no medium-sized projects. And so what happens, you have these large projects, but you have nothing in between. And so what we are trying to do is fill this space. And to get there, we have to start small, build our infrastructure, get more people using Fortran for smaller projects, and then you'll get medium-sized projects. The infrastructure gets better. And once we get to that point, then it's time to bring it to the production codes and say, look, you should be using it. And then in a little bit more detail for FPM, how we want to do that. So if you look at Rust, I mentioned the key is to have a layout. And if you use your layout for that package, for your package, new package, you don't have to set up any kind of, you don't have to tell FPM where your files are. You just use SRC and the common convention, and FPM figures out everything automatically, how to build it, how to link it, where your tests are, where your application is, everything is automatic. So then the question is, how do you bring this to a production code that does not use this layout? And the answer is kind of, there are two options. One is, just like Argo, FPM will have an option so that you can tell it where your files are if you don't follow the layout. And so that's one option. The other option is, once people realize how easy it is to actually just follow the layout, to just simplify so many things, I'm hoping that people will move to the layout and say, this gives us lots of free stuff if we use this layout. So that's how we eventually will be able to convince people to use it.
And I'd like to add something to this answer. Also increasing the publicity of the project, and that's the main point of the website. So I believe that very soon that website will be very easy to find and be at sort of the top of the search engine results. But also our Twitter account, which is quite active and tweets about the recent contributions to stdlib and other projects, events like this. And also, last but not least, larger events like conferences. For example, this year we will have, I believe, the first international Fortran conference called Fortran-Con in Zurich, Switzerland, organized by Tiziano Miller and his colleagues from University of Zurich. What's great about it is that anybody can join, because the conference was from the get-go designed to allow virtual attendance, both for speakers and guests, and the registration is free. So I encourage everybody here to at least lurking there, but maybe even submit a talk to the conference.
Well, this is fantastic. I love the idea of this conference as well. It's going to be really exciting. So, okay, I have one more question, then we're going to jump into the user questions. So is there, of all of the things that you showed today, you know, there's a lot of really good infrastructure that's being built for Fortran, for community building. Is there one place that if you would like to see more people or maybe developer hours going to, or contributors, you know, weighing in on things, if you could have people kind of go to one spot, is there one in particular that you like feel needs some love or anything like that?
All of it. So if you like any kind of compilers, any kind of F2Py work, any kind of this kind of it seems difficult, but it's really not. Then definitely come to Fortran, and I can use any help, and I can help you. I can find a good project. If you want to improve the packaging ecosystem, help us with FPM. If you want to feel like help with like a library development, come to stdlib. If you want to help with tutorials, documentation, come to the website. We have a GitHub repository and submit tutorials, documentation. If you want to help us manage these things better, maybe organize ourselves differently, also come to any of these repositories, open an issue, and join us.
Okay, great. I mean, it seems like there's so many good places, and we can all get involved in ways that are best for us. So that's exciting. So now we're going to jump into our user questions. We have quite a few, so this is going to be a little rapid pace. Melissa, you can go first.
So we have a first question from John Pantano. I hope I'm pronouncing that right. The question is, are there financial sponsors and/or industrial contributors to the project?
So it depends which part of this. So for example, I'm currently about 50% funded to work on Fortran. Then when it comes to, let's say, the commercial compilers, those are obviously developed by commercial companies. When it comes to, let's say, the website, no, currently we did it in our free time. So our vision is, as we get more successful, we'll be able to get more companies and more, let's say, my own employer interested in many of these things. In fact, I know that the only thing is that, for example, to kind of get the industry support, for example, from my own employer, we have to be able to deliver, we have to be so close to production that they could use these tools in production. And once we get there, they'll be very happy to fund. Until we get there, it's kind of too far. We have to kind of get there first. So that's, Milan, do you have any comment on that?
No, that was great.
Okay, so our next question is from Anaruda Das. Is there a chance that physical unit of measure will be part of the Fortran standard?
So that's a very, the reason I'm laughing is that it's a very old kind of a proposal on the committee, and apparently I'm new to the committee. I've been there for last year, but it turns out it's a very sensitive issue there, because they just were not able, I guess they were quarreling about how to do it well, and they don't like discussing it anymore because they just could not agree how to do it well. And it's one of the examples where the code of conduct that's why you have to enforce it, is that it's an idea, and it's a great idea. And so it should be discussed. And the fact that the committee has some history of not agreeing, well, that doesn't matter. It should still be discussed, and I think it's a great idea. The issue with something like this is that it has to have a prior compiler implementation, because it's a big change. And the idea there would be that it would be a compile time checking, essentially. So it would not give you any kind of runtime overhead. But it has to be implemented in a compiler to convince the committee that it can be done, that the compiler will not get more complicated. And so the reason why we want to have community compilers like Flang and Fortran is so that we can prototype features like this in one of these compilers. And so if you would like to help out, get in touch with me. I'll be happy to discuss how that can be prototyped down the road. And then once we have a prototype in one of these compilers showing that it works and getting some use cases and people using it, then it's a good time to bring it back to the committee and write a proposal. And I invite you to join us at the J3 GitHub repository and open an issue, and we can go from there.
In fact,
there is an issue already open for it.
I'd like to add to this answer. So depending on who you ask, but if you ask me, maybe units of measure are more appropriate for a library than to be part of the language itself. And a few libraries have been implemented to do this. Then once you have a library, you can play with it, and then you can see, hey, is this good enough for our needs, or should this be implemented in the language, and take it from there. So sort of some developments allow you a more incremental approach, and then there are some others that you really need to change the language a little bit to allow it.
So the next question comes from Danny Herms. Are there any plans to version this standard library the way Julia has?
Yeah, I asked in the chat. I'm not exactly sure how Julia does it, but when it comes to versioning we will version it. But I think there's more to the question. I'm not sure.
Okay, maybe we can come back to it if we get a clarification. So our next question is from Peru. So Fortran targets supporting Fortran 2018, but since there exists a large number of Fortran programs written in Fortran 77, will the support include also compiling Fortran 77 sources?
So that's a question. In fact, I already got this request a few times. So the answer is yes. I just have to do it. Yes. So the idea is that essentially you have to have a different parser for F77, but the rest of the compiler stays the same. So Fortran has an AST, and then it has a representation called Abstract Semantic Representation, ASR. And the ASR, I'm pretty sure it's exactly the same for F77 and the most modern Fortran. And so all I have to do is write a different parser to be able to parse F77. There's a lot of F77 codes out there, and so it'd be super helpful to have a maintained compiler for F77 that works. So absolutely, yes.
So that's a great segue into the next question, because so the question is by David Brochard, and it says NumPy and SciPy use Fortran heavily under the hood. Would it make sense to use Fortran for better integration, including packaging? And I'm saying this because I know that SciPy has a lot of Fortran 77 code underneath, especially for the optimization library. So I would be interested in hearing the answer too.
So first of all, I think one should not depend on any one compiler. So I strongly believe a Fortran code, any Fortran code anybody writes, it should compile with as many compilers as possible. So from that perspective, I would say it should compile with all the compilers. However, what Fortran can really help, I think, is with development, maintenance. Once it gets, I'm hoping, once it gets off the ground and people start contributing all kinds of warnings. Fortran compilers are not that good about warning about all kinds of pitfalls that people are doing, mistakes. The Rust compiler is an example how to do it right. Rust compiler warns you every time you make some kind of a tiny mistake, not realizing, it gives you a beautiful warning with explanation how to get it right. Fortran has many of these. Like if you assign 1.0 to a double precision floating point, the compilers don't warn you, but you lose precision. So things like that. But where Fortran can help down the road is, of course, I want to have a WebAssembly backend, and I got some requests from Mozilla, but they are trying to port NumPy and SciPy to run in the browser, and of course they have issue with Fortran because the Fortran compilers cannot compile to WebAssembly. So things like that, or on Windows, linking with MSVC. Again, there's no reason why Fortran compilers could not link with MSVC, but for some reason Fortran it's kind of very tricky, and so to fix this, we just have to fix it. There's no question about it. The only question is how do we get there? And so it will still take some time, but that's the goal. Oh, and for packaging, yes. Once we get FPM off the ground, and hopefully the community will start using it, I think it will kind of naturally come out of this. How to help with SciPy and NumPy and the Fortran sources in there.
Okay, great. So I think our, Pero, you have another one, but we're going to make sure everybody gets at least one question. So we'll come back to it if we have some time. So the next question is from Marcelo. And Marcelo asks, does Fortran have some kind of package manager like Cargo in Rust? You kind of answered this already, but maybe you can highlight it again, or something to easily install packages from channels like pip.
Yeah, that's the goal. That's the goal of FPM that we are developing. That's exactly what we want to fix.
Mm-hmm.
So I guess the next question would be from Matthias Alexandrakis. I hope I'm pronouncing it right. Is Fortran-Lang.org to be deprecated or merged with Fortran-Lang?
Yeah, I'm hoping to contribute what's in there to Fortran-Lang and then just point people to Fortran-Lang. So Fortran-Lang.org is one example. I try to kind of make a place for Fortran on the internet, but it's very hard to, it's hard to pull something like this off. And with I think just last year, kind of really, I was able to assemble we were able to get the initial community to get this working. And I think Fortran-Lang is a better website anyway, better domain. And so what I'm going to do is just port all the documentation there to Fortran-Lang, get it community kind of approved and get it in, and then point people to just use Fortran-Lang.
Our next question is from David Brochart, and the question is, why not use Conda instead of a language-specific package manager?
It's an excellent question. I spent hours discussing this very question with many people. So yes, so it sounds like a good idea to use Conda, except that if you look at Rust, for example, you would have to port every single Rust package to Conda. That's a lot of work. And Conda is great for end users, but it's not super great when you're developing a new package. If you want to get a new package to Conda and to really use it easily, you have to first submit, go to this Conda, I forgot the repository, to create a new package, and you have to get it in. It's kind of slow. And also, specifically for Fortran, Conda just compiles Conda is a binary package manager. So it gives you a binary, but the binary is not optimized for your architecture. And the key with Fortran is you have to get the performance. In other words, you have to compile it for your architecture with all the optimizations on for production runs. And so Cargo allows that, and FPM will also allow it. It's a source package manager, so it compiles everything for you, for your architecture with your compiler optimization options that you want. The other part is Fortran has about 7 active compilers. So which one would you use for Conda? And you want to use all of them. So again, FPM would allow you to switch the compiler. And finally, like a philosophical question, let's say there is only one compiler, like Julia is an example. Let's say just one compiler. Why would Julia develop their own package manager versus using Conda? So we spent hours discussing with the Julia developers also, like these pros and cons. The idea is it by having a language-specific manager, it can understand your language-specific things like the layout. It can then build so if you look at Cargo, it builds the binaries and the library and the tests, everything for you just by putting the files in a layout, a standard layout. And that gets you so far. It's like so easy to develop a new Rust package. And we want to make it as easy to develop a new Fortran package. However, what I would like to have, I would like FPM to be able to generate a Conda package out of this automatically, kind of, so that it becomes very easy, for example, to port. Let's say we decide we'll use G4Tran, let's say. So I would like FPM to make it very easy for people to take and create Conda packages, G4Tran based.
Okay, great. So we've had so many good user questions, and we're sorry we couldn't get to all of them, but we're running out of time. So again, thank you all for asking such good questions. We've had a really good discussion about Fortran. So to kind of close things out, we're going to do our rant/rave section, where each person that is on this webinar gets a 15-second soapbox to rant or rave about whatever topic that they feel like. So Andre, you're up first.
Oh, well, 50 seconds. So I would say it would be nice if C++ could compile faster. And and if they had a package manager like Rust has. Okay, great. Yeah, Milan?
Maybe a rant. My recent pet peeve is when I see collaborators get really into extreme tooling, and by extreme tooling I mean when you have to have all your CI set up, building for all platforms before you start writing any code. I like to take the opposite approach.
Melissa, you're up next.
Well, mine is, it's neither a rant or a rave, is more like a note, but I would like to remember John Conway, who sadly passed away this week. And he's known for the game of life, but he's done a lot of great work in mathematics. And as a mathematician, I just think it's a good thing to think about all the other things that he did beyond the game of life.
Yeah, thanks for that note. I think it's a really nice tribute, and yeah, it's a loss to the community. Okay, mine is like not exactly a rant or rave either, but you know, COBOL has been in the news lately, and we've all been hearing about it. And so somebody posted this week that COBOL is tucked into a scene in the original Terminator movie, which basically means that Skynet is running on COBOL. So I don't know if that's a rant or a rave. I don't really want to weigh in on the morality of Skynet, but yeah. So now we all know that that's what Skynet uses. So great. And we know it's not Fortran, I guess, right? So that's all the time we have for today. Thanks for watching. Thanks for listening. You can find us on Twitter at OpenTeams and at Quantsite AI. Andre and Milan, where can people find you in Fortran?
So they can find me on my website, andrejcherky.com, and I have all the contact information there.
Yeah, likewise, my website is my first name, last name, milancurcic.com. And you know the Fortran websites.
That's right. You've given us a great introduction to the Fortran website. So hopefully we all remember, and we can also Google it because now it's going to be one of the top results, right? So, and here's our call to action for all open source contributors. Sign up to OpenTeams today to build your online profile, claim your contributions, and get recognized for the great work you've done on open source projects that you care about. Join us again for next episode for an itsy bitsy discussion on Spider. Thanks, everybody.
Thanks for having us.